Hello, dear students. Let's continue our discussion on Pathfinder Check Your Understanding section of Thermal Physics, Part 2. From question number 1 to 9, I already discussed in Part 1. Now we will begin from question number 10. So, try this question. Okay. So, answer given to this problem is 50 degrees Celsius. Now let's discuss this question in detail. Three cylindrical vessels identical in all respect. So means the three cylindrical vessels are what? Identical. Except in their heights. Means heights are different. Means everything is same, only height is different. Okay. Volume of first, second and third vessels are 1 liter, 2 liter and 3 liter. So if only heights are different, so I can consider that height of first vessel is h, then first second vessel should be 2h and third vessel 3h, right? Because volume pi r square h for a cylinder, the pi r square thing is same. So v2 is 2 times v1, so height should be 2h, v3 3 times then v1, so height is 3h. A heater can heat water of first and second vessels to a maximum temperature of 80 and 60 in a surrounding temperature of 20 degrees Celsius. So ambient temperature 20 degrees Celsius. So now obviously these temperature differences like 80 minus 20 and 60 minus 20 is much lesser than our ambient temperature, which is 273 plus 20 means 293 Kelvin. So means we can consider here Newton law of cooling, okay, because temperature difference between body and surrounding is much lesser than temperature of surrounding. Okay, now first of all, why there is a maximum temperature? So first we need to understand that why there will be maximum temperature. Now when we are giving heat, so then that heat is absorbed by water, and also there will be loss to the surrounding. Loss to the surrounding according to Newton's law of cooling is directly proportional to temperature difference. So more is the temperature, more will be the losses. So a point will come when power given, means heat given per second, is just equal to heat loss, right? So then after that moment there cannot be any increase in temperature. So temperature is a maximum when power supplied is just equal to heat loss from the container, right? So as I said, now the approach, since the temperature difference is quite lesser than ambient temperature, we can apply Newton law of cooling, no problem. So everything else same, only heights are different. So first height h, second 2h and third 3h, right? Now as per the given condition, pi r square h is equal to 1 liter. So while doing calculation, I will not change the units. I will keep unit as it is, because the things will just get cancel out each other. Now temperature can be increased till power of heater is equal to heat loss. That is the crux point of the problem, right? So at maximum temperature, P is equal to heat loss. So heat loss according to Newton law of cooling. According to that is Newton law of cooling. So this you write m into c into rate of change of temperature. So which is heat loss. So it is when temperature of body and surrounding are near to each other, by binomial expansion we get this relation. So this heat loss you can write it as K, which is constant, and it depends on 4 sigma E and Ts. So these values are there. So basically this K is 4 sigma E Ts cube. So heat loss is proportional to area of cross section and temperature difference. This K is the same for all the containers. For all the three containers, this K value is the same. So A is surface area, T is surrounding temperature, right? So for first container, you can write P as K surface area. So from where heat loss will happen, from curved surface area, top, bottom, right? So total surface area I'm writing, and temperature difference. So this equation I'm writing like this. So now basically the physics part of this problem is I'm writing P in terms of what? heat loss for first container, and same thing I'm going to do for second container also. So what are the variables? Variables are many, right? But what we should try in this problem? We should try to eliminate those variables so that for the third container we can get the temperature, right? Maximum temperature. Now how you are rearranging these terms, it is up to you, right? By one method I am doing. So I am rearranging now H, as I said now, pi r square H is equal to 1 liter. So without changing units, I will write H as 1 upon pi r square like this. Now I am rearranging this equation, and finally I am writing it in terms of two variables. One is pr upon k and other is pi r cube, right? So in this way I am rearranging this equation. Similarly, the second time when I am doing for second container, only difference is this height is different for the second container 2h. Everything else is same. Temperature difference is also different. So again I am rearranging this equation. Again first term is pr by k, other term is pi r cube. So like two equations. Now from these two equations I will try to find out values of pr by k and r, right? So this pr by k is 240 units, pi r cube is 1 unit, right? Like this. And this pr by k and pi r cube so obtained, I am going to use it for third container. So for third container also I am writing like this. In place of height 3h, final temperature I don't know, right? So rearranging in the similar manner, right? So pr by k 240 units, pi r cube 1, and I am getting T as 50 degree Celsius, right? So you may have a better method of rearranging these equations, right? So as I said, physics part is this only. Power given is equal to heat loss, and from these two equations by rearranging you should get the correct answer. So if you have any better method, please tell me in the comment section. Okay, now next question. Next question is a very good question, right? So it is not a normal model of IIT JEE Advanced, but still it's a very important and good question. Thermal conductivity in wood depends. Okay, you first read this question by yourself, try to understand the language, then I will explain. So this is the question. Okay, now one precaution is there. Answer in the book is not correct. So this answer is given, and according to me this is not correct. That we'll see what I am getting. Okay, and I can prove it also that this answer is not correct. Okay, now let's first understand the question, what they are trying to say. Thermal conductivity in wood depends on direction of heat flow, and usually it is higher along fibers. So there are certain materials in which thermal conductivity is not same in all the directions, right? In different directions thermal conductivity can be different. So for wood they are saying it is higher along the fibers than in other directions. In a wood sample, thermal conductivity along fiber is eta time of that perpendicular to fibers. Means for a wood they are considering two directions, one along fiber and the other perpendicular to the fiber. Along fiber thermal conductivity is eta times in comparison to the direction perpendicular to fiber. Two identical cylinders are cut from this wood. Axis of first cylinder is parallel to the fibers and that of the second makes an angle theta with the fibers. The curved surface of both the cylinders are well insulated from the surrounding. If equal temperature difference are applied across their circular ends, find ratio of heat flux. So they are using this term heat flux, just like we use this term in electrostatics, electric flux. Similarly, they are using heat flux. So heat is basically Ka temperature gradient. Like this we write heat flow for conduction. Now they are writing this term Q by A as K dt by dl. So this we are calling heat flux. Okay. So this heat flux is dependent on what? Conductivity, thermal conductivity and temperature gradient. So it is more like a property of a point rather than property of a cross section. Just like you can say current density also. So now, just like as a comparing it with current density, so approach should be that only. So net heat flux rate in a second case is a second case, like this, that is our second case. So two cases are there. In one case, so that is along the fiber, in this side conductivity is eta into k. So if k is conductivity perpendicular to fibers, right, so like this, in this direction, so then along fiber it is eta into k, right. So in second cylinder mainly, what difference is there which is not normal in our JE books. So this thing, so now this fiber direction is at some angle theta with the axis of the cylinder. So along this flux can be different, along perpendicular to it flux can be different, right. So our approach of the question should be that only. In second case we need to take a component of both the flux, right. So I am writing flux rates means what, heat flux only, right. So now say net heat flux is a phi 2 along the axis. Now it should be what, heat flux along the fiber, its component along the axis, and heat flux perpendicular to fiber, that component also along the axis. If I am adding them, then I should get a phi 2. So that is basically the concept of question, right. So now along fibers there can be a certain value of temperature gradient, right. Perpendicular to fibers also there can be another value of temperature gradient. So based on this temperature gradient along fiber, I am writing heat flux along fiber. Similarly, I am writing heat flux perpendicular to the fiber. First case is a simple only, that is just along the fiber is the axis of cylinder. So phi 1 I am writing eta k into temperature gradient. Okay. Now along the fiber I can say what is that, basically component of flux along the fiber. Net flux along the axis is, if it is a phi 2, so then its component along fiber I can write phi 2 cos theta, right. Similarly, component of phi 2 perpendicular to fibers I can write phi 2 sin theta k into temperature gradient perpendicular to fiber, right. Now net temperature gradient, just like I am writing this flux, net temperature gradient I can write along fiber what is temperature gradient cos theta plus what temperature gradient is there perpendicular to fiber into sin theta. So that should be net temperature gradient for the second cylinder. Now temperature difference maintained in first and second cylinder is the same. So it means this temperature gradient for net temperature gradient for first and second cylinder also should be same, right. So this I am writing in terms of temperature gradient along fiber and perpendicular to fiber. So these values I will write in terms of phi 2, right. So in terms of phi 2 I am writing, right. So now temperature gradient along the axis I am using for first cylinder phi 1 by eta k, right. And solving this equation I am getting phi 1 by phi 2 as cos square theta plus eta sin square theta. So according to me that should be the correct answer, right. Okay, if you have any better solution you can post in the comment section, no problem, right. But according to me that is should be the question, that should be the answer. Now how I am so sure about this solution, that if theta I am choosing as 0 degree Celsius, 0 degree, cos 0 is 1, so phi 1 is equal to phi 2. Like this, in this expression if I am choosing theta is equal to 0, so then what I am getting, then second cylinder condition should be same as first cylinder condition. So it is satisfying with the this relation, but what answer is given in the book, it is not satisfied by this relation, right. Okay, that is question number 11. So now let's move to another interesting question, question number 12. one side of a thin metal. Okay, so read this question by yourself, try to solve it. Answer given in book is like this, very big answers, but otherwise question is easy only, no problem. Okay, so question is, one side of a thin metallic plate is illuminated by the sun when the air temperature is T0. The temperature of the illuminated side is T1 and that of the opposite side is T2. What will be the temperature of each sides be if another plate of double thickness is used? So just like our question number 10, right? Here also using Newton's law of cooling is a reasonable assumption. Why? Because this illumination is happening by sun, right? So it means temperature of the plate or ambient temperature, there should not be much difference. So T1 minus T0 should be less only in comparison to T0. So that is the approach of our problem. So we are going to use Newton's law of cooling. So we can use Newton's law of cooling here. So that is my approach. So for first plate, if you see, so now since it's a plate, area not given, so I am considering it as a unit area. So suppose P0 is power incident per unit area from sun. So then whatever power is incident at equilibrium temperatures, power emitted per unit area from both the surfaces should be same as power incident, right? So P is equal to P1 plus P2. So P1, what I am saying, power emission per unit area from surface 1, power emission per unit area from surface 2. This is surface 2, right? So then I am applying Newton's law of cooling. So K, area is 1 unit, K, right? Okay. So this I am writing and in question number 10 also we have used this Newton law of cooling. So P naught is this, that is my equation number 1, right? Now also whatever energy is transferring from plate 1 to 2, that only is emitting from surface 2. It means this P2 what I am writing should also be equal to what? Heat transfer from plate surface 1 to 2 through conduction. So now this conduction formula, the thickness is X, unit area, right? C is constant, right? So thermal conductivity, T2 minus T1 upon X. So this should be equal to K T2 minus T0, right? So that is equation number 2. So two equations I am writing for plate 1. Now for second plate, the only difference is thickness is 2 times. It means just like I am writing it for plate 1, for plate 2 also I can write in the same way. So whatever power is incident, that should be equal to power emission from both the surfaces. So that is equation number 4 that I am getting. And then same thing, that whatever power is there from surface 1 to 2 by conduction should be equal to power emission from surface 2. So that is equation 3, right? Okay, so now from 1 and 4, so if you are using equation 1 and 4, so what you are getting, T1 plus T2 is equal to T1 dash plus T2 dash, or you can write T1 dash in terms of T2 dash. So you have only two variables, one is T1 dash, other is T2 dash, right? So how you are solving these two equations, it is up to you. Now if you divide equation 2 and 3, you are getting this equation, which is equation in terms of T2 dash and T1 dash. So this is equation number 5 in terms of T2 dash and T1 dash, and equation number 6 also in terms of T2 dash and T1 dash. So from here T1 dash value I am substituting here, right? So what I am getting, I am getting T2 dash. So on rearranging it, my answer is matching with the given answer. This answer I am getting. Similarly, this T2 dash value, whatever I am getting, if I am using here in equation 6, I am getting back this T1 dash value, which is matching with the answer, right? So if you see, this is easy question only looking difficult. Okay. Now question number 13, a very interesting question. A square frame of side L is equal to 5 meter built in a laboratory is rigidly fixed on a frictionless horizontal floor. Within the frame, 50 identical particle-like balls, each of 5 grams, are confined. Balls are moving randomly, all with a constant speed 2 meters per second on the floor, colliding with each other and with the walls of the frame. Assuming all collision to be perfectly elastic, calculate average force exerted by balls on any of the vertical sides of the frame. Okay, so actually here in the question it was not mentioned, but it should be mentioned here that height of the frame is very small, right? So height of the frame is small, which is same as the dimensions of particles. Okay, so that you please take care and try to solve this question. Answer given is 0.1 Newton, which is 100% correct. Now let's discuss this in detail, right? Side length of frame is given, 50 balls are given, mass of each ball is there, and random velocity is 2 meter per second, right? So v is 2 meter per second is their random velocity, randomly they are moving. So along x balls will have some x component, y component. So just like in our KTG theory we write vx bar whole square plus vy bar whole square should be equal to v square, because motion along this axis is not possible, na? That is our crux point here. So motion only along x and y axis are possible because this length is very small, right? So force on vertical side is due to change in linear momentum of balls due to collision, just like our theory of KTG, how we obtain pressure on any wall of a container. The only difference here is height is very small. So it means a particle can freely move along two directions only, means along x-axis and y-axis only. So now force formula, rate of change of linear momentum, right? So number of collisions per second into 2 mvx. So the same thing I have derived in my theory lecture also. High end models, in that I have derived it, that how we can find out pressure exerted by molecules on wall of a container. So you can see that lecture for in-depth information about different cases associated with it. Okay. So now Vx is average velocity of balls along x-axis. So as I said, this can be written as Vx bar whole square, V by whole square. So since the particles are randomly moving, so their chances of moving along x and y axis are equal. So Vx bar, Vy bar are equal. So substituting here, so I am getting these are equal to V by root 2. So dn by dt, number of balls colliding per second, right? So this how I can write. N is say number density, right? So suppose n is number density, number of balls per unit volume. L into y by 2 into dx, so that is basically volume, divided by dt, right? In dt time the balls are striking. So first dn by dt only I am trying to get separately. So n number of balls per unit volume is 50 upon L square into y. So y I am considering height of the frame, right? So I am writing like this: L into y by 2 Vx bar. So this is this quantity. Okay. N is number density, number of balls per unit volume. So this I already discussed. Balls are free to move randomly in two directions. So number of balls moving towards one wall is estimated to be 1 by 4th of the total balls, right? And this we can see from the expression also. So dn by dt, number of balls striking per second, multiplied by change in linear momentum due to each ball. So Vx bar whole square. So 1, 2, this we are using everywhere like this. You might be interested in this factor too, because if balls are moving along x-axis, any ball which is moving along x-axis, right? So total number of balls which are there which are having components along x-axis. So some are moving along the surface where we want force, and other are moving away from it. So at an instant I can say in any small section total number of balls which are moving along x-axis towards our wall is half in comparison to total balls which are present, which are having their average component along x-axis. So that's why we write this factor 2. Okay, so then on solving it, we are getting an answer of 0.1 Newton. Right. So now let's move to next question. Very good question. You can say different sources, if you see, they are writing very big solutions, but actually it is a very easy and you can say important question. So please read this question number 14. Try to do it by yourself first. Okay, so now answer given in the problem is 10 meter, which is 100% correct. So very beautiful concept in this question. Okay, a water diver of mass 80 kg when breathes in up to his maximum capacity, that is 4 liter of air, means he can increase his volume by 4 liter. His body volume becomes 82 liter. It means after increasing volume by 4 liter, his volume became 82 liter. It means its initial volume was 78 liter. Means if I try to calculate density without air inhaling, it is 80 upon 78, means which is more than density of water, right? It means he has the tendency to sink if without doing any swimming thing. If he breathes in up to his maximum capacity and jumps into water, from what maximum depth? Measure from water surface to his chest, because we know na, is breathing, then air will be accumulated near the chest only, right? Can he comes to surface of the water without any swimming effort? Okay, so assume flesh and bones in the body of diver almost incompressible as compared to air in his lungs. Density is given, atmospheric pressure is given. So here, according to me, the most important thing in this question is language of the question, right? So if you can understand language properly, then this question is very easy. If language is not clear, then you cannot solve this question, right? Means if you misunderstood the language, then this solving this question is impossible, right? So let me first explain the question you briefly, that so that is a water surface, right? So when he is a diver, right, water diver, when he is going inside basically, right, that is his chest level. So when he is going inside, so when he is on the surface, then no problem, because his volume, its density is lesser than density of water. So he has a natural tendency to float, because buoyant force is more than weight, right? But as he is going down, so if he is going down, now what is happening? Pressure is increasing. So pressure is increasing means air inside his lungs is compressing. So means total volume of his body is decreasing. So it means its average density is decreasing, right? Or you can say buoyant force on it is decreasing. So buoyant force on it is decreasing. So up to what depth he can go? When buoyant force on it, it is just balancing his weight. That's it. So that is the question. Finish. Means if on going down, its volume reduced to 80 liter, means then buoyant force is just equal to its weight. He cannot go any further, because if he is going any further, so then his volume will be lesser than 80. So then buoyant force will be less than weight. So then automatically he has a tendency to sink. Okay, because they are saying without any swimming effort. So So without any swimming effort, he should come on the surface. Okay. So that is basically the question. So understanding the language of the question properly, that is the approach. If diver is going down, then his volume is decreasing due to compression of air in his lungs. He can come to the surface from a depth where his density is just equal to density of water, right? So density means this overall density, right? So minimum volume of air possible is 2 liter, right? Because total volume of air is a 4 liter. So its own volume was 78 liter. So its minimum total volume is 80 liters, right? So it means how much volume can be decreased? 2 liter. Okay, because density maximum is this only, as I explained. So initially when he just diving, inhaling air at atmospheric pressure into volume 4 liter, then pressure of air inside is P dash, and the volume can be just 2 liter. It means maximum pressure of air inside can be 2 P naught only, right? So we need to see that at what height or at what depth pressure is 2 P naught, right? So P naught plus H rho g is 2 P naught. So it means the depth where pressure becomes 2 P naught, only he can go up to that depth. After that, what will happen? Volume of air will decrease more, buoyant force will be lesser than weight, right? So H on solving what I am getting 10 meter, right? So very important and good question. Okay, 15th question. See this 15th question first properly, then I will explain. Very good question. So here they are saying the required condition is impossible to achieve. Smaller box is weightless, air pressure inside it and inside the larger box is always expected to be equal. So whether some lag is there in the language or in answer, because according to me language is perfect and you must get some answer of this question, right? So means when you are filling liquid inside like this, here you are filling liquid. So what is happening? From this liquid some portion will come in the inside box, right? So if liquid is going in the inside box, then what is happening? So now container is massless. So container is massless. So why it will go up? Basically, first of all, is think that why it will go up? Because of buoyant force. Because of buoyant force only it can go up. So now when you are filling it, initially liquid from this hole is only entering when it has more height outside, right? So it means what? That buoyant force on it is more than weight of inside box, basically a weight of liquid which is inside. So obviously it should be lesser and it should go at the top, right? And at the top when it is going and liquid is filling inside it, so then we have to see that what is the final pressure in the outer box. So here pressure we need. So according to me question is proper only, no problem, and I'm getting a particular answer. In answer they are saying required condition is impossible, but according to me yes it is possible. That here we have some air at a particular pressure P dash, here also some pressure is there, you can say it is P dash, here also same pressure. Now for a static liquid pressure is same at same level, so this height I'm saying H1, right? So height of air above the liquid I'm saying H1. So for a static liquid pressure should be same at same level, so this concept I'm using. So I'm just considering it a one box. pressure in upper part of small box should be same as pressure in upper part of big box, right? So this thing I'm considering, and I'm applying just at constant temperature P1 V1 is equal to P2 V2, that is for bigger box, and same P1 V1 is equal to P2 V2 for smaller box, right? And you two equations I'm getting, one for bigger box, other for smaller box. I'm using these two equations, I'm getting this P dash value. So according to me, this should be the answer. Okay. So any mistake I'm doing in this concept, please write in the comment section. Okay, now question number 16. Temperature of upper and lower surfaces of a plain horizontal sheet of area S are maintained at T1 and T2 respectively. Air pressure on both sides of the sheet is P0. Outside temperature T0. Acceleration of free fall. Air molecules strike a phase of the sheet with kinetic energy that is corresponding to ambient temperature, and bounce of the phase of the sheet with kinetic energy that corresponding to temperature of the phase of the sheet. What should be mass of the sheet be so that it stays floating at the level height in air? So very good question, right? Very important concept has been used in this question, right? Okay, so try this question, beta. We will discuss. So answer is this. According to me, answer is 100% correct. So let's discuss the solution in detail. Okay, so that is the plate. So I am using the concept of this force, just like in KTG we obtain pressure on any wall. So thrust force upon a cross-sectional area, so that I am using. So but the thing is here, air molecules are coming with velocity V, which is corresponding to ambient temperature T0, and after collision going with velocity V T1, right? So like this. So you see first this diagram properly. So F1 vector that I am writing minus sign, right? So rho a V square formula, thrust force formula. So V is a velocity corresponding to temperature T0, V T1 velocity corresponding to temperature T1, right? Similarly F2 I am writing. So see properly direction of thrust forces, right? So net force will be F2 plus F1 vector addition. So or you can write rho a V T2 whole square minus V T1 whole square, right? Okay, so this is our standard result. So PV is equal to nRT, right? So that only. And similar to that, this P naught I am writing like this. So M into N is P naught M by R T naught. Okay, so now this V square, as here molecules can randomly move in any direction. We are interested in velocity along a particular direction. So that is V RMS square upon root 3, right? So that already we have done many times. Okay, so now this Mn I'm using as P naught M by RT naught. Okay, so here also you can see this factor 2. Again, as I discussed in one more problem of KTG. So then when we are interested in a number density in a particular direction, then we have to divide it by 2 of the overall number density, because we are interested in number of particles which are moving in particular direction only, right? So along x only, if you see total number of molecules, half are moving along positive x-axis and half are moving along negative x-axis, right? So we want number of molecules moving in a particular direction, like along positive x-axis. So you have to divide it by a factor of 2. Okay, so by solving I am getting this answer. Okay, now next question. So next question is a very you can say interesting question. Please beta, that you can say it is the best question of our discussion, right? So my favorite question of this part. Read this question properly so that we can discuss in detail. Answer given in the uh, book is masses and area of one piston is this and that of other. So one and other they are giving, but exactly I can tell that what will be mass of A and what will be mass of B, right? So that I'm going to explain in detail. Okay, so let's see first the question. Let's read it properly. What they are asking: two fixed vertical cylindrical vessels are connected at their bottoms by thin tube. 1 mole of gaseous nitrogen is confined in the vessels under piston A and B. Now, where exactly is the location of piston A and B? That they are not giving. So they are giving one diagram, right? So they are giving one diagram when the two pistons are at a particular level, but they are not saying anywhere that these pistons are here only or where are the pistons. So on the basis of graph, we need to make the idea that where exactly are the pistons initially and finally, right? Both the vessels have protrusions near their top on their inner surface to stop further upward motion of the piston. Means some obstruction is there, allowing a maximum height H max 1 meter in each of the vessels. Outside the vessel, air is at pressure 10 is to power 5. In an experimental study, pressure of gas is measured over a wide range of temperature and pressure. Graph is there. Portion of graph is shown in the calculated masses and areas of the piston, right? So on the basis of this graph, we need to tell what are mass and area of both the piston, right? So now my dear students, you see this graph here till 240 degree or Kelvin, sorry, pressure is constant, right? So how pressure in a container can be constant? Only if a piston is moving freely, right? So piston is moving freely, outside pressure is atmospheric pressure and inside pressure also atmospheric pressure, then only I can say pressure is constant, right? Now this constant pressure is happening two times. Now we have two piston only in this case. It means from 0 to 240 when pressure is constant, one piston is moving freely and other is fixed, and from 300 to 450 the other piston is moving freely. So first of all this has to be clear. And when you see from 240 to 300 and you see this graph, right, if you extend it or you see it from the slope, it is passing through origin. This graph also passing through origin, right? It means the volume of the gas is becoming constant two times. So two times pressure is becoming constant and two times volume is becoming constant. So when volume can become constant, right? So what should be the location of pistons? So here proper brainstorming required. Okay. So this question you are doing brainstorming means you are upgrading your skills, thinking from different angles. Okay. So the approach is, as I said, visual inspection and brainstorming to identify locations of piston at different time intervals. So from temperature 0 to 240, pressure constant, one piston moving up and other at bottom, right? So what I am thinking from all those steps, that in my first interval from 0 to 240, so out of 2, because I do not know the masses, I do not know. So when B, suppose B is at the lowest position, suppose, it means MB into G is more than delta P into area. Means inside this gases are there, no? Delta P into area. Delta P into area, that is upward force. MB into G is downward force, right? So now this can be more than this, or this MAG also can be more than delta P into its area. area of A, because areas are also different now. I cannot simply say that MB is more than MA just by looking at their areas, right? Okay, so I'm not sure about anything that which is heavier or which will move first. So I'm considering any one of them is just moving up and the other is at the bottom in first interval, right? So that is my first interval. Second interval, then from 240 to 300 where volume is constant. So in that thing what I'm thinking that already one out of one, okay, just take A, suppose I'm taking A. So A is at the top and B is just at the bottom, and then what is happening, temperature of the gas is increasing, the volume is constant, right? So from 240 to 300, it means this pressure is not sufficient enough to move, to pull this B also up or to push this B up, right? So from 240 to 300, volume remains constant. And what is that volume? Area of cross section of A multiplied by 1. So just A and B I am saying, but I do not know that which will move up first, right? Okay. So volume, one piston at top, other at bottom. Interval 3, temperature from 300 to 450, pressure is constant, means the other piston also now started moving up, right? Interval 4, 450 to 540, means both the pistons are like as shown in the diagram. From 450 to 540, volume is constant. Now you are increasing temperature, now nothing can happen, right? There cannot be any change if you are increasing temperature because obstructions are there now. So it means the volume will remain constant. So that are the four intervals. In each and every interval I am doing the thing. So like 0 to 240, pressure is constant, right? So one piston moving up and other at bottom. So consider M2 greater than M1, any one piston, right? Or M2G greater than delta PA2. So this step not required. Simply I am saying, so one can have more mass or one can have M2G more than delta PA2 of other, like that. So now if say any one piston is moving freely out of A or B, if any one piston is moving freely, then its force balance is this, because pressure is 2, outside is 1, so delta P is 1. So M1G is 10 to the power 5 into A1, right? Okay. So now this piston, one piston is moving freely, other is just at the bottom, okay? So temperature 240 to 300, so their volume becomes constant, means first piston is at the top, so volume constant, okay? So at just 240, so just 240 when first piston is at the top, right? So at that point I can write PV is equal to nRT equation, because I know volume is constant na, and that volume has to be area of first piston multiplied by height. So that I am doing. So area I am getting this expression, right? So this area, it means mass I am getting, putting in 1, I am getting mass at 12 R. So 99.7 kg, or I am taking 8.31, right? Or if you are using exact value, you may get 100 kg also, as it is given in the book, right? Now interval 3, from 300 to 450, so pressure is constant, so it means piston B also started moving up as I explained. So for second other piston also, M2G delta PA2 I am doing, so M2G this value, right? So interval 4, so finally volume is constant, but total volume is A1 plus A2 into A, so PV is equal to nRT I am applying at just 450, so A1 plus A2, right? So now A1 already we know, so A2 we are getting. So this area is lesser than the first one. So it means this piston 2, that what I am referring is what? So it is basically A2 is smaller piston, right? It means this bigger piston is going up first. So A2 is 60 R by 10 to the power 5. Okay, this area I am getting. So and then using M2 I'm getting, which is 9R 74.79 kg. So means left piston has area A2 and mass M2, right? So it was a very interesting question. Personally, I enjoyed this question very much while solving, as well as when I explained in my class. That time also I enjoyed. Okay. Now question number 18. Another very valuable concept, very interesting and enjoyable question, right? So it is not a question, you can say it is an enjoyment. Okay, so read this question and try to do by yourself. Okay, so means basically we need to draw a graph, right? So the graph is given like this. Okay, now let's see this question in detail. A bottle of capacity 1 liter made of a non-stretchable but flexible plastic, means what bete? So just like a plastic carry bag we have na, so if you fill air, right, so then it can expand up to a limit, after that it becomes unstretchable thing, right? So like that only. Contains a monatomic ideal gas at pressure 2 P naught. Bottle is connected to a rigid vessel of capacity 4 liter by a thin tube equipped with a valve. Vessel is made of good conducting material, right? It means temperature will be same as outside temperature, or you can say I can increase temperature from outside very easily. Initially the valve is closed and vessel is almost evacuated to pressure 0.1 P naught. Temperature inside the bottle and vessel is 240. That is also outside temperature. Now the valve is opened and after pressure in the bottle and vessel equalizes. Temperature of gas in the vessel is slowly increased to 600. Construct a graph between pressure and temperature of the gas inside the vessel during the heating process. Okay. So here also you can say we need to understand that what is happening in the question, right? A very careful analysis required to see different states of gas. That is basically our approach. We need to understand what is going on, what are different stages in the question. So bottle is non-stretchable but flexible, means its volume can be decreased but cannot be increased, just like a plastic carry bag. So final pressure before heating can either be more than P naught with total volume 5 liter, or it can be P naught with total volume less than 5 liter. Okay, bete. Now let's understand. Here pressure was very less, 0.1 P naught. One second. Yes, 0.1 P naught, and here pressure was 2 P naught. Okay. Now if I am mixing them, right? So if this valve is there, if I'll open this valve, so what can happen? So pressure from this bottle, means air from the bottle or this gas from the bottle will go into the vessel, right? So because of that, pressure of the system will decrease, right? So up to what value it can decrease? So if suppose final pressure is more than P naught, then no problem. Shape of the bottle will remain as it is, right? Shape of the bottle will not change. So if it is more than P naught. But suppose on mixing its pressure is becoming lesser than P naught. So then what will happen, beta? Because bottle is stretchable. So if pressure is less, means from outside pressure is more, so it will try to compress the bottle, and it can be compressed, no problem, because they are saying it is stretchable, right? Right. Okay. So first we need to see that on mixing them, so what is going to be the pressure? That is first thing I am doing. So P1 V1 plus P2 V2 is equal to P V1 plus V2. So what I am doing, beta? So PV is equal to nRT is on N1 RT1 plus N2 RT2 is equal to N1 plus N2 RT. So this internal energy I am making equal, right? So by that what I'm getting this P pressure I'm getting, so final pressure I'm getting 2.4 P naught by 5. So obviously this is less than P naught, right? So first, what is my assumption? I'm assuming that total volume will be 5 liter only. So if shape is like this only, so what will be the pressure? So when you're mixing, I'm considering it is 5 liter, then pressure will be what? Less than P naught, right? So means gases are mixing. So just after mixing, this pressure is becoming 2.4 P naught by 5, which is less than P naught. It means compression should happen, right? Outside pressure is P naught, inside pressure is less than P naught, so bottle must compress. Now how much compression will happen? That also I don't know, right? Till what point compression will happen, that I know. Till pressure will become P naught, right? So now my next step will be, I will try to find out the final volume. So what will be the final volume of bottle? So what I will do, because I know the final pressure can be P naught. So initial volume 5 liter, initial pressure this, and then by that I am applying P1, V1, P2, V2. I am trying to find out final volume. So final volume I am getting 2.4 liter, which is also not possible. Why beta? Because bottle you can compress, you can make its total volume 0, but the vessel with which it is connected, it is not flexible. You cannot decrease its volume. So it means what? Total volume of bottle will be compressed with some pressure inside the vessel lesser than P naught. Because for pressure to be P naught, final volume has to be 2.4 liter, which is not possible. Okay. So now what I know, so minimum volume possible is 4 liter. So final pressure I am trying to calculate, right? So from this initial condition, so final pressure I am calculating. So final volume I am taking 4 liter now, right? So P final I am getting 0.6 P naught, right? So it means finally volume of the bottle is almost 0 and pressure 0.6 P naught, right? So that is our the condition. Okay, so just before heating begins, now we need to plot the graph that if I am heating from this moment, so then what is the pressure versus temperature graph? So that is my step 1, right? So step 1, it is like this, volume is 4 liter. Okay, so pressure is 0.6 P naught. So till pressure becomes P naught, when you are heating, volume should remain constant. So in my first step, volume of the bottle becomes non-zero after pressure increases from P naught. So till pressure is P naught, volume is constant 4 liter. P directly proportional to temperature. So final temperature is 400 Kelvin. So that is my step 1. So this is my step 1. Okay. Okay. Now step 2. In step 2, if pressure reaches to P naught, after that what should happen? If you are further heating it, so then pressure will try to increase. But since the bottle is flexible, it will start expanding. So pressure will remain P naught till volume of the bottle is maximum. So maximum possible volume is 1 liter. Okay. So pressure will be constant till total volume of the gas is 5 liter. So V1 T1 is equal to V2 T2 I am applying. Okay. So this it is given T is equal to 500 Kelvin. So my step 2 is what? This pressure is constant, right? Okay. So now when volume is 5 liter, volume is also now constant. After 500 Kelvin, volume constant. So bottle is unstretchable. So now you have to heat it till 600. So P1 by T1 is equal to P2 by T2. So final pressure I am getting 1.2 P naught. So this volume constant, and if you make this slope, that also will pass through origin. Okay. So by that I am getting this graph, what they have given, 100% correct graph we are getting, right? So that is a part 2 of our thermal physics chapter, right? So soon I will come up with part 3. Okay. Goodbye.